Hello students, this is Miss Dalton, and this video is over the introduction to functions, or for some of you it'll be a review for functions. We have two goals for this video. The first one is we're going to identify functions in coordinate, table, or graph form. The second goal is we're going to determine the domain and range of given functions. So let's look at a few vocabulary words. Relation. A relation is just a mapping or pairing of input values with output values. Again, this can look at like a list of ordered pairs. It could be a table, or it could be a map. A function. A function is a type of relation where every input has exactly one output. So this is important, and we'll see this in some more examples. The domain. When you think of domain, that is the set of input, which is also your x values. And then we have range, and range is the set of output, which is also the y values. So domain goes with x, range goes with y. You'll also need to know how to determine whether or not something is a function. So we said before that you can determine a relation is a function if you are looking at the input and the output values, and the x values should not repeat. The other way that you can look at it when you're looking at a graph is by using what we call the vertical line test. And basically what that looks like is if you have a graph and you have something graphed on that coordinate plane, you want to be able to make sure that every time you draw a vertical line, that vertical line can only hit that graph in one spot. So if it hits it in more than one spot, then it would not be a function. So let's look at this example. We're going to consider this relation, which is -2, -3, -1, 1, 1, 3, 2, -2, and 3, 1. And so the first question is that it is asking, what is your domain? Well, if you remember, the domain is your x values, and so what we would do is we would list the x values. And when you list them, you want to list them from least to greatest order. So the smallest x value is -2, so we would list that first. The second one would be -1. Then we would have 1, then 2, then 3. Okay, and then what is the range? Well, if you remember, the range represents your y values. So we're going to look at the y values. We're going to do the exact same thing. We want to list them in order from least to greatest. The least y value is -3. But then we have this y value up here, -2, which would need to come next because it is the next highest. And then we have 1, and notice that 1 is repeated. You only have to list it one time. And then the last y value would be the 3. That is the highest. And then you're done with that. So then the next question says, is it a function? Well, remember, when we're looking at a function, we're determining whether or not it has repeating x values. So if you look at all of these x values here, do any of them repeat? The answer is no. So if they do not repeat, then it is a function. So I'm going to write that here. Yes, it is a function. And then the last thing is represent the relation using a graph and a mapping diagram. Okay, so for the graph, all you would do is you would just graph those ordered pairs. Remember, you graph the x value first, so -2, 3, or -3 would be approximately right here. It's hard for me to do that with my pen. And then negative 1, 1 would be here. And then 1, positive 3 would be here. And 2, negative 2 would be approximately here. Again, I'm kind of making these not evenly distributed. 3, 1, because it is hard to write with this pen on the iPad. And so those are just a list of points. So you would just leave them, don't connect them. They're just a list of points. That's your graph. Now a mapping diagram, what that's going to look like is it's going to have two ovals here. On the left side, you're going to put your x values. Hopefully you remember this from Algebra 1. You've got negative 2, negative 1, 1, 2, and 3. And then the y values go on the right side. Again, we're going to list them from least to greatest order. And then the last thing you would do is you would connect the x with the y value. So negative 2 needs to go with negative 3. You're going to just connect it with an arrow. Negative 1 goes with 1. Again, an arrow. 1 goes with 3. 2 goes with negative 2. And then last but not least, 3 is going to map to 1 as well. So your 1 will have 2 arrows coming into it. Okay, on this next one, example 2, it says tell whether the given relations are functions. So again, when you are looking at functions, the x values cannot repeat. So we're looking at mappings here, and if you look at these x values, you can see that you just have one arrow coming from each one. So this one is a function. However, this one here has one x value that goes to 2 different outputs, and so this one is not a function. Okay, so let's look through a couple more examples. The first one says use the vertical line test to tell whether the relation is a function. So the vertical line test, I told you before, is drawing lines, vertical lines, and making sure that none of them cross at more than 1 point. So this one crosses at 1 point, 1 point, 1 point, 1 point, and you can see that this is a function. Okay, now we're going to test your graphing skills on what you remember from Algebra 1. When you graph a line, the equation is going to be in y equals mx plus b form, and if you remember, b is your y-intercept. That's where you begin. So b is at negative 3. Let me try and put my point right there at negative 3. And then m is your slope, and that represents where you move. So if you remember, slope is equal to rise over run. So because it is 2 over 1, we're going to rise 2 from this point. So we're going to rise 2, which would put it right up here at negative 1. And then we're going to run 1. Okay, now I put that red dot there, but we don't leave that there. We're going to just count up 2 and over 1. So our final point should go right here. And then now we can draw a straight line through it. And I'm going to try and do the best I can. Not too bad, using my finger. And that's how we graph the line. Okay, my last two problems. The first one, number 4, says tell whether the function is linear. Well, if you remember, linear will just have an x value like this, an x to the power of 1. This one has an x to the power of 3, so this one is not linear. Now the next thing that it wants you to do is to evaluate the function when x equals negative 1. So basically what you're doing there is you're taking f of negative 1 and you're taking that negative 1, you're substituting it in for everywhere that you see an x. So we have 2, we'll put times negative 1 to the 3rd power, plus 6, And then be careful here, this is minus a negative 1, so I always put that in parentheses. And now you want to evaluate that. So here, negative 1, you'd want to raise it to the third power, which will give you negative 1. Negative 1 times 2, this is going to be negative 2. Then we have plus 6. And if we have minus a negative, that's the same thing as a plus 1. And then now we want to simplify that. So we have negative 2 plus 6, which is 4, and 4 plus 1 is 5. So evaluating for when x is equal to negative 1 on this first one, it is 5. Okay, on this last example, this is your secret example. So when you do your form, you're going to see, it's going to ask you about the secret example, and that's what this last one is. So determine if this one is linear. So again, we're looking at the x value. The highest degree of the x is 1. So this one is in fact linear. And now let's go ahead and let's plug in negative 1 for x. So we're going to find g of negative 1. So you're going to plug in 4 times negative 1 and then plus 9. 4 times negative 1 is negative 4. Plus 9, and that answer is 5 as well. Okay, don't forget to fill out your form so that I can make sure you understand this video, and I will see you when you get to class.